Let us solve one more problem from the optics from TIFR 2025 question paper. The problem states that a stream of electrons having an energy of 0.5 eV impinges on a pair of extremely thin slits separated by 10 micrometer. The distance between the adjacent minima on the screen 20 meter behind the slit would be closest to. So we need to find the distance between the adjacent minima on the screen which is placed behind the slit would be closest to. Right, the electron energy it is given 0.5 eV. Slit separation E here given we have E equal to 0.5 eV. D slit separation is equal to 10 micrometer or 10 to the power minus 5 meter, or screen distance is L. Let's say screen distance is 20 meter. We want the phase spacing between the adjacent minima. So double slit interference. So in the double slit interference, we can write minima at minima at d sin theta is equal to m plus half lambda, right? Not an integral part. So for small angles, we can write sin theta is corresponding to tan theta corresponding to y by L, right? So the spacing between the adjacent minima, so the spacing between adjacent minima is delta y equal to lambda L by D. We will compute lambda. So the electron in de Broglie's wavelength can be written as the electron kinetic energy of electron. We can write E is equal to P is momentum squared by 2m. Right, the momentum equal to, we can write root over 2me, or wavelength we can write lambda is equal to h by p or h by root over 2me. We know, right? So the constants, we have the values of the constant. So we have the values of the constant h equal to 6.626 into 10 to the power minus 34 joule second. Me mass of 9.109 into 10 to the power minus 31 kg. E we know, we have 0.5 ev is equal to 0.5 into 1.602 into 10 to the power minus 19 joule, or we have 8.01 into 10 to the power minus 20 joule. So we need to compute root over 2me is equal to root over 2 into 9.109 into 10 to the power minus 31 into 8.01 into 10 to the power minus 20. So it is coming as 1.459 into 10 to the power minus 49. So it is coming as 1.20 8 into 10 to the power minus 24. So, or then lambda, then we need to find the value of the now lambda. So lambda will be having h by root over 2 me. So it is having 6.6.626 into 10 to the power minus 34 divided by 1.208 into 10 to the power minus 24. So we'll get 5.48 into 10 to the power minus 10 meter or 0.548 nanometer, right? So compute the fringe spacing. We need computation the fringe spacing. Compute the fringe spacing. So delta y equal to lambda L by D, or we have 5.48 into 10 to the power minus 10 into 20 by D is equal to 20 to the power minus 5. So after calculating, we get 1.096 mm. So this is the distance between the adjacent maxima. So so this is the so this is the distance between adjacent maxima. For the adjacent minima, the spacing is same. So for the adjacent minima, the spacing is the same. So we can write 1.096 mm. But none of the option exactly matches this. But we can but alternate we can write the formula in this way, that lambda, we can also write the formula in this way, lambda 1.23 root over E into EV. This is also a formula of EV. So with this formula, we will get 3.48 mm. So this matches with the option A. So in some cases this formula correct, and in some cases that formula correct. So which option is matching? So according to that, we need to decide which formula would be work for this problem, right? Hope this solution as well as the problem is clear. So next, so thank you for now.